Let's look at the global arrays that we'll be building as part of the vector space model. First of all, it will be dict, up arrow D-I-C-T. This is the dictionary. It's indexed by a word, and the value stored at it will be the number of times the word occurs in the collection. The total number of times a word occurs in the collection. The next one is DF, or document frequency. This is the number of documents in which a word occurs. So a word could occur 100 times in the collection, but only occur in 20 documents. So this is the number of documents a word occurs in. This is the number of times it occurs totally in the collection. The next one is a weighting vector. It's the result of the inverse document frequency calculation on the importance of a term in the collection as a whole. Again, it's indexed by a word. The IDF calculation we'll get into later, but it tells us how important the word is in the collection. It doesn't tell us how important the word is in a particular document. That is calculated in other ways, basically by the number of times the word occurs in the document times its weight in the collection as a whole. MCA is another way of measuring the importance of a word in the collection as a whole. It's the modified centroid algorithm. And it is an alternative way of coming up with a weight for a word. It is much more expensive to calculate, however, but we'll do some examples of that. The next one is one of our prime matrices. Well, they're all important, but this is the first one we calculate, which is the document term matrix. It's actually three levels deep. It's up arrow doc. The first index value is the document number, 1, 2, 3, 4. It's an accession number. We just count the documents as they're coming in. The second value is a word. Stored at this portion of the array, document number, comma, word, is the number of times the word occurs in the document. Okay, remember in mumps we can store things at different levels. We think of this as a tree, where document is at the root, then there are words underneath it, and we'll have something else beneath it. But at the document word level, we can store the number of times the word occurs in the document. At the third level, for each word, we will have the position of the word in the document. So if I have some word X that occurs in document Y, it may occur at positions 1, 10, 20, 30, is a relative to the start of the document. So for a given document, for a given word, the third level of the tree, now we think of this as a tree, will be the instances of where the word occurred in this document. We don't store anything here. The fact that we know what the position, that's sufficient. We will be using this position number later on to determine if words are related to one another. Words that frequently occur close together are probably related. Words that don't occur very often together, or if they do, they occur at a considerable distance from one another in documents, are probably less likely to be related. The next one is the transpose of the document term matrix. It's called the index. It does not contain the third level, the position. It's only the document and word portion. So these are rows that are indexed by words, and the values in the columns are the document numbers, and the values in the positions for a given word for a given document, that particular cell, is the weight of that word in that document. So this is just simply the transpose of this portion of the document term matrix. Document term matrix, the rows are documents, the columns are words. Okay, that's the basic, what we call the document vector. For a given document, we have a vector of values. And the values are the number of times different words occur in the document. The transpose of that is its word by document. For a given word, we'll show all the documents in which the word occurs. It's easy to calculate, obviously. The next one is the document matrix. What we calculate here is the relationship between all documents and all other documents. So for document 1, what is its relationship to document 2? Are they related? Are they correlated? Is document 1 in any way like document 2? For most of the case, the answer here will be 0. The documents are not related. But in some cases, the documents are related. They're both about the same topic. So the value stored for some given document 1 in a row and some given document 2 as a column will be the extent, the correlation between the two documents. And we'll use this for a variety of things, one of which will be to calculate clusters. Another thing, of course, is if we find a document as a result of a search, we can find very quickly documents that are related to it. Next is somewhat similar. It's the term-term matrix. It gives us the degree to which two terms are related to one another. It's a square matrix, words by words. I've used W instead of the word word here. So for a given word 1 and a given word 2, it would be the strength of the relation. The easiest way of looking at that is the number of times they co-occur. But we can refine that concept to something a little more sophisticated. But essentially, the value stored indicates how correlated the two words are. Now, most words won't be correlated at all. Now, they'll simply be background noise. They'll be slightly correlated. They'll occasionally occur together, but it's not a significant correlation. We'll have cutoffs, of course, to where significance begins. Next is a vector, which we actually already looked at, of titles. Indexed by the document number. If you give the document number, it'll give you the title. We'll use this in retrieval so we can present the title. The titles are usually truncated at some length because some of them can go on for quite a length, and we just simply want to see the basic part of the title. Finally, we have the term-term proximity matrix. This would be for word 1 and word 2. There would be another additional level below. It's only one level. For any given word 1, any given word 2, we will have at that level, just at this point here, we would have, which would be the same as this up here, as the term-term matrix. It would be the degree to which they're correlated. But at this extra level beneath, we store the degree to which they are close together. It's the sum of the absolute value of the term proximities between word 1 and word 2. So if basically we go through the collection and we find, say, word 1 and word 2 exist in a given document several times, we'll simply take the difference between where word 1 occurs and word 2 occurs and the absolute value of that. And if that number is small, it means they're close together. If that number is large, it means they're far apart. And that's what we're going to be dealing with here. We'll get to it again later. There will be a number of result files that are created. This is kind of a tabular list of what's being created. We won't go into them now. There are a lot of them. So you can look at the intermediate results. Anyway, we will look at those as we're creating them. So the next thing is we will actually look at the code. And the first piece of code is the document term matrix.mumps.